energy of an isolated system remains constant. This means that the energy in the initial state is equal to the energy in the final state as long as no work is done on the system. The first type of energy is gravitational potential energy. The symbol for this is UG, which equals mgh, where m is the mass of the object, and g is the acceleration due to gravity, and h is the height that the object is at. The next type of energy is kinetic energy. The symbol for this is UK, which equals 1/2 mv squared, where m is the mass of the object and v is the velocity. Energy is elastic potential energy. The symbol for this is US, which equals 1/2 kx squared, where k is the spring constant and x is the displacement. The last type of energy is thermal energy. The symbol for this is delta U internal. This energy is energy due to frictional force. It equals FF times x, where x is the displacement and FF is the frictional force. This is an example roller coaster problem that shows conservation of energy and circular motion. There's a cart going up a hill starting on the roller coaster track, and the types of energy that are involved in this problem are UG and UK. Over the hill and then around a loop. The height of the hill is 90 meters, the radius of the loop is 20 meters, and the height of the loop is 50 meters. So AI asks, where is the cart the fastest? And it would be at point P, because at point P the cart has no height, so it has all UK, meaning that all of the cart's gravitational energy from point A has transferred to point P, kinetic energy, so it has maximum kinetic energy, so it has maximum velocity. So now it asks for the speed at point P, and because at point A there's only UG and at point P there's only UK, we know that the UG there would equal the UK here. So UG equals UK, UG is equal to mgh, and UK is equal to 1/2 mv squared. So the masses would cancel. And then G equals 10 meters per second squared times the height at point A, which is 90 meters, which would be equal to 1/2 v squared. You solve for v, you get 42 meters per second. So now we're asked to find the cart's speed at point B, and we know that at point B there is gravitational energy because the cart has a certain height above the 0 meter mark. And we also know that the cart is still moving at that point, unlike at part A where the cart stopped momentarily and then went down. The gravitational energy at point A, the initial gravitational energy, is equal to the UG at point B plus the UK at point B. So we know the UG at point A is equal to mgh, and the same with at point B, and UK is 1/2 mv squared. So the masses can cancel, and then G equals 10 meters per second squared. The height at point A is 90 meters, and then G again. The height at point B is 50 meters, plus 1/2 v squared. You can subtract the UG final from the UG initial, multiply it by 2, and take the square root of the velocity, and you get the velocity is equal to 28 meters per second. Now we're asked to find a force diagram for the cart at point B. So when the cart is right here going inside the track, so the cart has a force of mg on it, and it also has a downward force of the track on it. So the net force is down, and and this net force is the centripetal force that allows the cart to continue moving in a circle. Okay, so now we have to find the magnitude of the force of the track on the cart at point B, which is this vector. So by finding the net force using Fc equals mv squared over r, and knowing the value of mg, we could solve for the force of the track. So on the right, I solved for the net force exerted on the cart, which is the same as the centripetal force, which is equal to the mass times the velocity squared over the radius. We have the mass as 700 kilograms. We have the velocity at point B, which we solve for here. And then the radius of the circle is 20 meters. So when you solve for the net force, you get 27,400 newtons. And then if you plug that into the net force statement, which we got from the force diagram, you would add mg plus the force of the track on the cart, because they're in the same direction, to equal the net force. So we know mg is 7,000 newtons, and we solve for the centripetal force, so we can solve for the force of the track on the cart, which is 20,400 newtons.
Within a system, energy can be transformed from one form to another. Name two types of energy seen in this picture.